Alright guys and girls, welcome back to the next lesson. Today we're going to be talking about 6.4, vectors and their dot products. Now this one, if we had time in class, this would probably take us all week because there's a bunch of different things to go about it. However, since we're in different circumstances, you guys get the shorter version. The main reason why we've been talking about vectors is we can use it to find different components for work. We necessarily won't get that far, but what we will talk about is how we can break stuff down into that point. And that's going to rely primarily on dot products here. Okay. The dot product, when given two different vectors, so we have vector u and vector v. Okay. The x component is u1, y component is u2, v1, v2. To find the dot product, it's going to change it from having two component form vectors into a single scalar. Okay. Page 429 has a bunch of properties for different dot products, but its dot product is a mode of multiplication for vectors that changes it from two separate vectors in component form into a single scalar. Okay. So the first dot product we're going to do the vector 3, 4 times the vector 2, 3, or 2, negative 3. Now again, this is dot product. This is different from vector multiplication or vector addition in scalar multiplication. Okay. Essentially, here's how it's going to work. You're going to multiply your first two. We're going to add to it whatever we get from multiplying the second one. That glare is perfectly in the way. Okay. So now, literally finish it off. 6 plus negative 12. Negative 6. Multiply the x's. Multiply the y's. Add them together. Boom. Dot product. Done. Easy. Simple. Nothing too over the top. Okay. The next thing. So now it's going to be talking about using some of those properties. So we got a little bit of a longer one here. So we're given u is negative 1, 3. V is 2, negative 4. And then w is 1, negative 2. Let's find our answer, u dot v times w. And then I'm also going to have you tell me, is it a scalar or is it a vector when we're all said and done? Okay. So, order of operations, start off on the inside of the parentheses. So we're going to take u dot v. So x component times x component. So we have negative 1 times 2 is negative 2. We're going to add to it 3 times negative 4. Well, 3 times negative 4 is negative 12. And then that is times w. Notice this has a dot. This does not. Two distinctly different things going on here. Add them together. So now we have negative 14 w. We have a scalar times a vector. So it's, well, distributing. We're going to take negative 14 times everything inside w. So negative 14 times 1 is negative 14. Negative 14 times negative 2 is 28. Our final answer here when we're done is the vector negative 14, 28. Now also when you tell me what it was, well, it's a vector. Key things to note, to look for. Is it a dot or is it regular multiplication? We can't do just a vector times a vector with normal multiplication. It has to be a dot product for this to work. If it's not a dot product, it's not going to work. Pretty clear cut. There's going to be multiple forms of these. They're going to have you do different things. Order of operations, everything inside parentheses first, and then you go from there. All right. Next up, one of the main reasons why we're doing this, well, why do they have vectors in with the trigonometry stuff? Well, if you look right here, we can use this to find the angle between two vectors. Okay? So the cosine of theta is equal to u dot v times, or over, excuse me, magnitude u times magnitude v. Okay? This formula right here we're going to use quite a bit. Make sure you have it in mind so that way we can find, well, the angle between two vectors. The example that we're going to use here, keeping it simple, we have 2, 1, and for v we have 1, 3. Now when we get done with this, I want you to round your answer to the nearest hundredth. All right, so here we go. I'm just making sure I have my calculator. Oh, yep, okay. So we're going to have u dot v divided by magnitude u times magnitude v. So cosine theta equals, let's do u dot v. So we have 2 times 1, which is 2, plus 1 times 3, which is 3, all over. Now we need to find magnitude u. 2 squared is 4. 1 squared is 1. 4 plus 1 is 5. So we have root 5 times 1 squared is 1. 3. This is square root of 10. Again, to find magnitude, Pythagorean theorem. Square them, add them together, square root. 4, 5, square root 5. 1, 9 gives us 10, square root of 10. Multiplying 2 square roots together, you just, as long as they're square roots, you can just multiply the numbers on the inside together. So we're given cosine theta is equal to 5 over root 50. Now, if we want the angle is theta. I want the answer in degrees. So theta is equal to the inverse cosine of 5 over root 50. All you have to do is plug that into your calculator and you are good to go. So, inverse cosine of 5 divided by the square root of 50. And I got 45 degrees. That is the angle between these two vectors. So there's a 45 degree difference between the two of them. All right. Now, like I said, this one I try to keep a little bit shorter. Last couple ones have been a little bit longer. This one I want to try to keep shorter. Big part about this is being able to find the angle in between. In order to do that, we have to be able to do dot products and realize, okay, when is the answer going to give us a vector in component form, or when is the answer going to give us it in scalar form? If it's a scalar, it's just going to be a number. So like here, the dot product, 2 plus 3 gave us 5, gave us a scalar. On the previous problem, u dot v in parentheses times w. U dot v, we did that first, turned it into scalar, so we had a scalar times a vector, which gave us a vector. Okay? Pretty straightforward. Depending on how things go, I might release a second half to this section so we can work on projections and work. But otherwise, if you guys made it to this far into the video, for some bonus points, tell me what your favorite kind of drink is. I have been in a bad habit of drinking a lot of Dr. Pepper recently, so I'm trying to cut that back. And I'm just trying to see who all watches the video all the way through. Okay, you guys have a great day. Don't have too much fun.